There's a new and incredibly dangerous worm burrowing its way through the open source software world. And yeah, it's named after the giant sandworms of Dune, Shai Hulud. In this breakdown, we're going to look at how this sophisticated attack works, the massive damage it's already causing, and what you can actually do to protect yourself. Let's dive in. First things first, let's just wrap our heads around the scale of this thing. This is not some small, isolated incident. No way. The latest version of this worm, which folks are calling Shai Hulud 2.0, has already hit tens of thousands of GitHub repos. We're talking hundreds of unique developer accounts compromised. This is a massive, automated attack, and it's spreading like wildfire. And get this, the attacker isn't exactly trying to be subtle. When the worm manages to steal a developer's credentials, it actually creates new public repositories on their GitHub account. Why? To exfiltrate all the stolen data. And the description for these repos is, well, it's a chilling calling card. Shai Hulud, the second coming. Now, this threat isn't completely out of the blue. The original Shai Hulud worm was spotted before, but this second campaign, it's a huge and way more aggressive evolution. So let's break down what's changed and what makes this new version so much more dangerous. Okay, so the first version of the worm was bad, but version 2.0 is on a whole other level. It used to execute after a package was installed. Now it runs before installation, a critical change we'll get into. The goal has also shifted. It's not just about stealing your secrets anymore. It's about theft and outright sabotage. And finally, the code itself has gone from pretty basic to highly obfuscated, making it a nightmare to detect. So let's talk about that pre-install advantage because it's the real game changer here. By using a pre-install script, the malware basically guarantees it gets to run. It doesn't matter if it's your machine or an automated build server. It also cleverly sidesteps a lot of security scanners that are only looking at the code later in the process. It's such a simple change, but the results are devastatingly effective. All right, so the worm's trigger is pulled. Now what happens? Let's deconstruct the worm's pretty sophisticated attack method step by step. This attack chain is just brutally efficient. First, like we said, the pre-install script runs. Immediately, it kicks off a super aggressive scan for any and all credentials it can find. Then, it uses a really clever encoding trick to sneak that stolen data out. After that, it uses those same stolen credentials to spread itself. And if all of that fails, well, it's got one last nasty surprise waiting for you. So what is it hunting for? Basically, everything. The worm just vacuums up NPM tokens, GitHub access tokens, and API keys for all the big cloud providers, AWS, Google Cloud, you name it. It even uses a tool called TruffleHog to scour a user's entire home directory looking for any other hard-coded secrets it can possibly find. So you're probably wondering, how does it get all this incredibly sensitive data out without setting off every alarm in the building? Here's the sneaky part. It uses triple base 64 encoding. By wrapping the stolen data in 3 layers of encoding, it manages to slip right past GitHub's native secret scanning and other detection tools. It makes finding out what was stolen a whole lot harder. And this is where the whole thing turns from just theft to pure, malicious sabotage. If the worm can't find any credentials to steal, or for some reason can't get them out, it doesn't just quietly shut down. No, it has a fallback plan. It tries to securely overwrite and delete every single file in the user's home directory. It's a scorched earth, punitive final act. But what makes this a true worm is its ability to spread. And honestly, the most dangerous part of Shai Hulud is how it's designed to self-replicate, turning every single victim into an unwitting accomplice in its mission to infect the entire software supply chain. Now, to really get this, we need to be clear on what a software supply chain attack actually is. Think of it this way. Instead of attacking a castle head-on, you poison the well that everyone in the castle drinks from. Attackers poison a component, like an NPM package, that they know developers trust and use. When other devs install that component, they're unknowingly installing the malware too. And this creates a truly vicious cycle. The worm uses a compromised developer's NPM token to find other packages they maintain. Then it injects itself into those packages, bumps the version number by a tiny patch to make it look like a minor bug fix, and republishes the newly infected versions. The whole thing snowballs, spreading exponentially without any more human intervention. And if you thought this was just a JavaScript problem, think again. The damage isn't contained. We've actually seen this infection spill over into the Java and Maven ecosystem. How? Well, automated systems that mirror popular NPM packages for Java developers accidentally grabbed the infected versions and republished them, spreading the worm to a whole new community. So with a threat this sophisticated, this widespread, what can we actually do about it? Let's shift gears from the problem to the solutions and talk about some concrete, actionable steps you can take to defend your code. So the big question on everyone's mind, how do you protect your projects and your accounts from an attack like this one? Look, the situation is serious, but there are clear steps you can and absolutely should take right now. Okay, here's the official guidance on what you need to do. First, rotate all of your credentials now. Just assume any secret on a developer's machine might be compromised. Second, do a deep audit of all your project's dependencies for any known compromised packages. Third, go through your GitHub accounts. Look for any public repos you don't recognize or any suspicious commits. And finally, please, enforce multi-factor authentication everywhere, especially on GitHub and NPM. Now, let's just zoom out for a second. An attack like Shai Hulud isn't just a one-off event. It's a signal. It's a wake-up call. And it tells us a lot about where cyber attacks are heading and the new reality we all need to be ready for. So what does this new reality look like? 3 things really stand out. 1, automated worm-like spreading is the new normal for achieving massive scale. 2, the goal seems to be shifting from quiet theft to loud, public, and disruptive attacks. And finally, there's evidence that a large language model was used to help write parts of the malicious code, marking another step in the weaponization of AI. And all of this brings us to the fundamental question that Shai Hulud forces every single one of us to confront. Our entire open source world is built on a foundation of shared code and mutual trust. When that very foundation is poisoned at this kind of scale, how do we even begin to rebuild it? That's the challenge ahead of us.